So today we're going to learn about absolute value equations and how to solve them. So first of all, you need to figure out what an absolute value is. So the absolute value of a number is the number's distance from 0. So if you're looking at this number line, and we have -8 and 8 on there, so that -8 is 8 units away from 0. So it's 8 little ticky marks away. And that 8 is also 8 ticky marks away. So the numbers 8 and -8 are both 8 units away from 0. And so the notation is right here. It says up and down lines, which we've talked about before. And so the absolute value of positive 8 is 8, and the absolute value of -8 is also 8. And you can use your calculator for that. Since absolute value is a distance, it is always positive. So now solving absolute value equations. So now it just means there's going to be equal sign in it and an unknown. So if you look at the first example, it says find the solutions of the absolute value of x is 5. So you're figuring out all numbers that have a distance of 5 away from 0. So both 5 and -5 have a distance of 5 away. And so a lot of these problems today are going to have two solutions. So now let's talk about the different steps. So step number 1, you have to isolate the absolute value. So what that means, isolate means to get something alone. And so you're going to have to get the absolute value symbol alone. So you're trying to get that whatever's in between the two bars, so that x minus 2, you need to get that alone. So what's in the way of having that be alone is this plus 4. So you need to first subtract 4 from both sides. So after you subtract 4 from both sides, you'd have equaling 5. That's the first step, and it's a very important step that a lot of people forget, and it will mess up your answers if you forget it. Step 2, you make two equations. This is how you're going to get your two solutions. What you do is you set one equal to the positive number, and the other one, and one equal to a negative. So what that means is I take the x minus 2 that's inside of the two bars, and I make two equations. And what I set it equal to is I set it equal to that positive 5 and the negative 5. Notice I said equal to 5 and -5, not 9 and -9. So then step 3 is you solve both equations. So I solve this one, I add 2, and you should be doing the same action because you don't change what's inside of the two lines. So I should add 2 on both, but I'll get different results. In this first one I get 5 plus 2 is 7, and the next one -5 plus 2 is -3. The last step is you have to check your answers for something called extraneous solutions. What an extraneous solution is, it's a solution that appears correct but isn't after you go and check it. And whenever you check, you need to make sure that when you check your two answers, you plug it into the original equation. So the one that's typed out for you is the one that you plug in. So I'm going to take my 7 and I'm going to plug it right in for that x. And so you've probably had a math teacher in the past that's been a check Nazi who said that you need to check all of your answers, and if you don't, you get points off. Well, I'm not one of those people. I feel like if you're not going to check it and you get it wrong, that's your own fault. But this is different because sometimes you can do the work flawlessly and you'll plug it in and it just won't work. And so that's what an extraneous solution is. So whenever you are checking these, you can do right in your calculator. So I'm just going to take the 7 and I have to put it into the original equation. So I'm going to do the abs, and I'm going to put in 7 and the -2, and on the outside is the +4, and we're trying to get it to equal 9, and sure enough it does. So 7 is a good answer. I'm going to do the same thing I'm going to do with -3. So I do -3 -2, go outside of it, and I do +4. They both equaled 9, so they are both good answers. Let's do a couple more. So this first one, There's nothing that needs to be added or subtracted or multiplied or divided outside of the 2 bars, so I just start making my 2 equations, x plus 3 equals and x plus 3 equals. So it's going to equal positive 2 and negative 2. So on both of these, I need to subtract 3 from both sides. So x equals negative 1 there, and x equals negative 5 there. So then I grab my calculator, and I plug it in to my original equation, so negative 1 plus 3, and I'm trying to see if it equals 2. It does. And now I try negative 5 plus 3, and it also has to equal positive 2, because that's what the original equation says. So they both equal positive 2, so they're both good answers. All right, example 3. What I need to do is I have to set x plus 3, whatever's in between the 2 bars, is what I make my 2 equations. But to figure out what number I have to get them set equal to, I have to isolate. So I have to add over the 5. That's going to get me 16. And then I need to divide by this 2. And so I get 8. So I'm going to set it equal to 8 and negative 8. And I'm going to solve both of those. So subtract 3 on both of them. I get x equaling 5 and x equaling negative 11. So then I go to my calculator. I plug into my original equation, so 2 is on the outside, so I type in 2 first. Then I get my abs. I type in 5 plus 3. I have a minus 5 on the outside, and it has to equal 11. And sure enough, it does. I'm going to do the same thing, but with a negative 11. So negative 11 plus 3 and a minus 5. And it also equals 11. So they're good answers. Example 4. This has x's on both sides. So what you do with that is I'm going to have my 3x plus 2 equals. And what it's going to equal is you're going to set it equal to the original, 4x plus 5. And then the second one, you're going to change the signs of both terms. So since the 4x is a positive, I'm going to change it to a negative. And since the 5 is a positive, I'm going to change it to a negative. Now I need to solve both of these. So when you solve them, get numbers on the one side. So I'm going to subtract the 2. So I have 3x equaling 4x plus 3, and then I'm going to subtract over the 4x. So I have negative x equaling 3, which that means x equals negative 3. Now I'm going to do the same thing with this one. So I'm going to subtract over the 2. That gives me negative 7. I'm going to add over 4x this time. I have 7x equaling negative 7, so x equals negative 1. So when you check these, they're a little bit more difficult to check, but these are the ones you really need to check because a lot of times only one or none of these will work. So when you plug it in, what you're going to do is you're going to take this negative 3 and you're going to plug it into the left side for that x, and you're going to plug it into the right side. So I am going to plug negative 3 into the left side first. So it has the absolute value, so I need to have the 2 lines. So 3, and I'm plugging in negative 3 plus 2. So I get 7 when I plug it into this side. I get 7. Now I need to plug it into the right side. So I still am plugging in negative 3. It does not have the 2 bars this time because it's not in between them. And I get negative 7 that time. So when I plugged it into the left side, I got 7. When I plugged it into the right side, I got negative 7. They are not the same, so negative 3 doesn't work. Now let's try negative 1. So this time you're not trying to achieve a certain number. You're trying to get the sides to equal each other. So it doesn't matter what the number is as long as the sides equal each other. So second 0, I'm going to plug in negative 1 this time. So 3 times negative 1, and then plus 2. So when I plugged it into the left side, I get 1. Now I'm going to plug it into the right side. 4 times a negative 1 plus 5. Notice when I plugged in the left and the right side, I both got 1 on both sides. So it doesn't matter that they both got 1. It matters that, or it doesn't matter if that you got a certain number. It matters that they both got 1. So the fact that they both got 1 means negative 1 is an answer. Last one. So I have 8m minus 3 equaling 2 things, negative 21 and positive 21. So I solve both of these. So I have 8m equaling negative 18, and 8m equals 24. So m in this case, when I divide by 8 and I reduce that, I get negative 9 over 4. And when I do this one, I get 3. So then I go to my calculator, I plug it in. So I plug it into the original equation, so 8, and I'm just going to plug in parentheses the fraction that I got, minus 3. I'm looking for it to equal negative 21 because that's what the original problem says. It equaled 21, not negative 21. That's not a good answer. Now I'm going to try the second answer. So 8, and I'm plugging in 3 this time. I'm looking to get negative 21. I got 21, not negative 21. So neither of these are answers, so it's a no solution or none. The reason you could have told that that was a no solution right away is because of the negative sign in front of the original number that it equals. Absolute value can never equal a negative number, so after you isolate it, if it equals negative, then that means it is no solution right off the bat. You don't have to do any work.